Alright, welcome back to SQC Tutorials. In today's video, we're going to solve 5 questions on variable separable differential equation. So if you are in pharmacy, this video is, I specifically made this video for you because of some of you have issues with differential equations. So the first question, I'll drop the link on the description where you can get several questions on variable separable differential equation. I'll drop the link on the description. And if you have issues with differentiation and integration, I'll also drop the link on the description so that you can get familiar with it. So let's kick off. The first question here is 4x plus, there's a mix-up in your question. This is actually what they wanted to write, not 4x out of the bracket, plus y plus x squared y dy equals 0. Then when x is equals to 1, y is equals to 2. So we have to solve this differential equation. Now, what's variable separable or separable variable? It depends. Engineering use variable separable, pharmacy use separable variable. What matters is that we're actually going to separate variables. Now we are going to take all functions of x to go towards this differential x and all functions of y to go towards this differential y. It's more like a collection of like things. Now what is common here? You can observe that x is actually common here. So when I bring that x out, I'll have x 4 plus y squared dx. Then plus, what's common here? Y is common, so I'll have y, open bracket, 1 plus x squared dy equals to 0. Now, I want to take this guy to the other side of the equation. So I have x bracket 4 plus y squared dx is equals to minus y plus this. Now, we want to separate variables. Now, mind you, we are doing variable separable differential equations. Now, we want to separate variables. All functions of x should go to dx and all functions of y should go to dy. Now this dx, I want this function of x to come here and this function of x to be here. So I'm going to take this and bring it down. This guy will come down. And this guy, which is a function of y, will also come down to come and meet this. Y will remain because it's already close to dy. So I'm going to have x over 1 plus x squared, then our dx is equals to minus y over 4 plus y squared dy. Now we can now integrate both sides of the equation. Now if you have not watched my integral videos, go ensure you watch it so that you understand what we'll do here. Now whenever you have a function so that when you differentiate this denominator, you will get this. If you integrate that kind of function, you will get ln f of x. Now when you differentiate 1 plus 2x, you are going to get 2x. But here there is x. How do I manipulate? I want 2x, not x. So I'll put 2 here and put 1 over 2 here so that these two can also. So now it's making sense. When I differentiate the denominator, I will get 2x. So I can now rewrite this as 1 over 2 ln 1 plus x squared. Same thing applies here. When I differentiate this denominator, I'm going to get 2y. So I'll have to add 2 here and bring this minus sign out so that it will look like the differential of this function. So I'm going to have minus 1 over 2 ln 4 plus y squared equals this. Then let's add a certain constant. Let's call that constant A. I want to take this guy here. I'll have 1 over 2 ln 1 plus x squared plus ln 4 plus y squared equals to a certain constant. I took this guy here. There's 1 over 2 here. There's 1 over 2 here. That's why I brought them together. Now, according to the rule of indices, when you have the rule of logarithm, when you have logarithm of something plus the logarithm of another thing, you just simply multiply them. So in your exam, if you don't see your answer like this, you may see it like this. You can leave it like this. Now you can join these two together. You now have 1 over 2. Now when these two come here, 2 times a constant will give you another constant. So we still have 1 plus x squared times 4 plus y squared equals to another constant. Now, how do I remove this ln? I'll just have this equals to e raised to power b. Remember that in logarithm, when you have log something base something equals to, let's call it x, that b will be equals to a raised to power x. Now, remember that ln is log to base e. So I will make this the subject of the formula by bringing e towards this direction. Now, exponential b is also a constant, so I can therefore say that 1 plus x squared bracket 4 plus y squared is equals to a certain constant. Let's call that constant c. You can stop here, or if you don't want to stop here, you open the bracket again, and don't forget that 1 times 4 is a constant, and when that constant comes here, it will give you another constant. So I will stop here and move to the second question. The second question, we are going to also separate variable. Now, observe this is a function of y, and also this is a function of x. Now, I will take this dx here and leave this dy here. So when I take this dx there, I'm going to have something like this. Now, what do? I want to carry out variable separation, or separate the variables. Now, this function of y should come to dy, that is like y. This is what I'm going to get. So I'm left with dy over sec y equals to tan x dx. Now, what's the inverse of sec y? Don't forget that 1 over cos is sec and 1 over sec is cos. So this is the same thing as cos y dy equals to tan x dx. Now I cannot integrate both sides of the equation. Now when you integrate cos y, you are going to get sin y. When you integrate tan x, you will get ln cos x. How do I know? Tan x is the same thing as sin x over cos x. Now remember I said that whenever you have a function and the differential of the function, when you differentiate this function, the numerator, it will give you the numerator. That when you integrate that kind of function, you will get ln f of x. Now when you differentiate cos x, you are going to get minus sin x. So there should be a minus sign here. So when you differentiate cos x, you get minus sin x. Now remember, if you want to differentiate this ln cos x, you have differentiation of the function all over the function. So you have minus sin x, which will multiply this minus to give you plus sin x. So eventually you get the same answer. Then don't forget your constant. Let's call it a. If I take this guy to the other side of the equation, I'm going to have sin y plus ln cos x equals to a constant. And that will be our answer for this question. Now let's move over to question 3. Welcome back. Question 3. We want to also separate variables. We have di over dt is equals to t minus ti all over t squared minus I. Now the first thing you must observe is that there's t here and there's also t here, so we can factorize it out. So we have di over dt is equals to t bracket 1 minus I all over t squared minus 1. Now what do I do now? I'll separate variables. First of all, let me take this dt to this direction. So I'll have di is equals to t over t squared minus 1 bracket 1 minus I dt. Now there's a function of t here, but this is a function of I, so I have to take this function of I to this differential I. So I'll take this to the denominator. So I'll have the I over 1 minus I equals to t all over t squared minus 1 dt. Now I cannot integrate both sides of the equation. Also, do not forget, I said when you have a function f of x, and when you differentiate that function, you will get the numerator. That if you integrate this kind of function, you will get ln f of x. Don't forget, Now when I differentiate this function at the denominator, I'll get -1. But at the top, I just have 1. So I have to manipulate and put this -1 here and put over -1. So that this -1 can cancel out, you still get 1. So it's as though I did not alter this equation. Now when I differentiate this now, I'll have -1. So I can now say it is ln 1 minus I equals, when I differentiate this function now, I'll have 2t. But there's just t here. What I need is actually 2t. So I'll put this 2 here and put 1/2 behind the integral sign, such that these 2 can cancel out. I'll be left with t. So I have not altered this equation in any way. So when I integrate this, I'm going to have ln t squared minus 1, then plus your constant. Let's call that constant a. Now when I take this guy here, I will have ln 1 minus I minus ln t squared minus 1 equals the constant. Now remember your rule of logarithm that says when you have log of something minus log of another thing, it is actually the logarithm of the first all over the second. Don't forget this rule of logarithm. If I will also drop my logarithm videos, the link on this description, so that you can watch it in case you are confused there. So this will give you a. Now how do I remove this ln? Remember that when you have the log of, let's say, x all over base b equals to a, when you want to get x, you simply raise a to this. So we have b raised to the power a. So this is actually log base e. So I have 1 minus I all over t squared minus 1 is equals to exponential a. Now remember that exponential a is a constant, and exponential a will also give you a constant because e is a constant number, just in case you don't know. So this can be replaced with another number. You can leave this as c. So this, if this is your option, this is correct. You can twist this thing like this. When you twist this, you have 1 over c. 1 over c is also a constant. So even if you see this over this equals to a constant, you are also correct. If you see this like this, you are correct. If you see this like this, you are correct. If you see this like this, you are correct. Whichever way you see the options. So let's move over to question 4. This is question 4, which is exponential x dx minus y dy equals 0. Okay, mind you, the first question we forgot to do something. We were supposed to substitute. They gave us some conditions. They said at I think y equals to 1, at x equals to 1, y is equals to 0. So you can actually do that on your own. When you put y equals 1, when you put x equals 1 and put y equals 0, whatever you get as that's your constant, which we call c, that's the value for c. So you actually got the particular solution. Then you can now write the general solution back again. Then instead of you writing that constant as c, you replace that constant and put the value you got. Now let's solve this, or let me use this as an example. Now we want to separate variable. Now exponential x is already with the x and y is already with the y. So it's already okay to separate. The variables are already separated. What we'll do is that we can take this guy here and leave this guy here, or we can just integrate like that. So we have exponential x dx is equals to y dy. So I can now integrate both sides of the equation. Now when I integrate exponential x, I'll get exponential x again. Then when I integrate y, I'll get y squared over 2. Don't forget that the integral of y raised to the power n is y raised to the power n plus 1 all over n plus 1. Here n is 1, so we have 1 plus 1, which is 2, all over 1 plus 1, which is 2. Then don't forget your constant c. So we can therefore say, let me take this guy here. We have y squared over 2 minus exponential x is equals to, if I take this guy, I have minus c. Minus c is also a constant. Let me call that constant a. Now if I multiply 2 by 2, I'll have y squared minus 2 exponential x is equals to 2a. 2a is also a constant. Let me call that constant b. So this becomes our general solution. This becomes our general solution. Now let's assume we were given the condition that at x equals to 0, y is equals to, let's say, 1. that at x, this means x is 0, x is, at x equals to 0, y is 1. Now how do we go about it? We substitute our x as 0, e raised to power 0 is 1. Then we substitute our y as 1, so we have 1 squared. 1 minus 2, that will give you minus 1. So it means that b is minus 1. So I can now replace b and write minus 1. So the particular solution for that differential equation will be this. I can take everything here, our y squared minus 2 exponential x plus 1 equals 0. Now this will be our particular solution, while this is our general solution. Now let's move to the last question for this video. Alright, this is our last question for this video. We have x cos x dx plus 1 minus 6y squared dy. Now these they've already separated variables. Wow, I love this. We are going to carry out what we call integration by parts. So if you have not watched my integration by parts video, please do so. I will drop the link under the description of this video. Now the function of x is already with the differential x, and the function of y is already with the differential y. So we'll leave it and integrate that way. So let me integrate everything. Now I want to take this guy here. When I take this guy here, I'll have minus 1 minus 6y squared dy. Then let me integrate both sides. Now when I use this minus to open this bracket, this will actually turn around. I will have minus 1 and I will have plus 6y squared. So I can rewrite this as this. Now this guy becomes plus 6y squared. Then this guy becomes minus 1. So we have dy. Now what do I do next? Now integration by parts, please go and ensure you watch my integration by parts video. Now I'm going to carry out what we call the setup to integrate this particular one. I will differentiate x and I will integrate cos x. Now when I differentiate x, I will have 1. When I integrate cos x, I will have sin x. Remember your plus minus. Now this times this minus integral of this. So this times this minus integral of this times this. So we have x times sin x. Then minus integral of 1 times sin x, which is sin x dx. Now this whole thing here is the integral of x cos dx. X cos x dx. This whole thing here is for this. Then we have equal to, now when I integrate 6y squared, I will have 6y raised over 3 all over 3. Don't forget you add 1 to the power and divide by the result. Then minus y plus your constant. Let's call that constant a. Now, how do I integrate sin x? If I integrate sin x, I'm going to get minus cos x. Then that minus will multiply with this guy, so I'll have plus cos x. This minus cos x times minus, we have cos x. So we have this. Now 6 divided by 3 is actually 2, so we have 2y cubed. 2y cubed. You can decide to leave your answer like this, or let me take all the functions to one side. So we have 2y cubed minus y minus x sin x minus cos x, then plus a. But I want to take this a to the other side so that it becomes minus a. If a is a constant, minus a should also be a constant. So let's call that constant c, and that will be all. If you want to be sure of your answer, I will advise differentiate this, differentiate everything. If it leads you back to this, then you are correct. How do you differentiate this? Your normal differentiation. How do you do this? Product rule, then you differentiate this. Let's just confirm. If I differentiate 2y cubed, I'll get 6y squared. But because I'm differentiating y, I have to add dy dx. Don't forget our implicit differentiation. Same thing applies here. When I differentiate this, I will have minus 1. But because I'm differentiating y, I will add dy over dx. 1 times that is just same thing. Now I want to differentiate this guy now, x cos x. I'll put the minus sign. When I keep x and I differentiate sin x, I will get cos x. Then plus, when I keep sin x and differentiate x, I will get 1. So 1 times anything is that same thing. Now when I differentiate cos x, I'll put the minus already. When I differentiate cos x, I will get minus sin x. That minus times minus will give you plus sin x. Then if I differentiate a constant, I should be able to get 0. Now what's the next thing? If you observe carefully, dy dx is common here. So I'll have dy over dx, bracket 6y squared minus 1. Then minus x cos x. I want to open the brackets. Then minus sin x plus sin x equals 0. Now this guy can cancel out. So we are left with dy over dx, bracket 6y squared minus 1 minus x cos x equals 0. Now what do I do now? I take this dx and put it here. When I cross multiply with the dx, I will have this dx will come here. Now if you observe this particular equation, it's looking like this, but now there's no minus sign in front of this minus cos x minus x cos x. What I do is I will multiply through by minus 1, such that when I multiply through by minus 1, this 6y squared minus 1 will flip and change to this form, and then this minus sign will go. So you can see that you are supposed to get the same value. But mind you, the actual answer to what we have been solving is this. So that will be all for this video. In our next video, we'll talk about linear differential equation. I will also post the link to our next video on this description. Once the video is out, I'll post the link also. So if you're watching this video now, you should be able to know the next video on the description. Thanks for watching.